So then we move now to our second invited talk for this session. And this is going to be given by Hervé Claustre from the Oceanographic Laboratory in Villefranche-sur-Mer in France. Hervé's research focuses on the development of interdisciplinary approaches to study biogeochemical processes at small to global scales, in particular observational approaches based on gliders and profiling floats. And Hervé at the moment is also the co-chair of the Biogeochemical Carbon Argo Float Program. Thank you very much, Hervé.
Okay, good morning, everybody, and thank you to the organizer for allowing me to explain and give my view with respect to the observation of the biological carbon pump in some way. And also, I would like to acknowledge the fact that most of the results that we use to argue my view derive from the observation networks BGC Argo, and in particular in the context of the REFINE project, which is the funding agency that fund more group. So to set up a little bit the context of this presentation, this was done by the paper by Phil Boyd, where in some way it allowed to organize our conceptual view that beside the biological gravitational pump, we could organize and categorize in some way the biological carbon pump into two complementary pumps, physical particle injection pumps, one which is physically mediated, and in some way it's the subduction pump at various scales, so large scale and eddy subduction pump. And also you had the mixed layer pump at seasonal or at the event pump. And also we have a biological mediated pump, either with migration, with deal migration, or seasonal migration. And we heard from this during the previous period of meeting. From modeling study, and here is the modeling study by Resplendi et al., we know that these various pumps do not have the same, I would say, phenological sequence, the same imprint in various regional areas. And here you have the results of a high-resolution modeling study in the North Atlantic with three regimes, subtropical, jet, and subpolar. And you can see, for example, that in the subpolar gyre, we have a strong impact of the gravitational pump and of the so-called subduction pump, but here it's more for the physical pump, I would say, as compared for the subtropical area. And also what you can say that you have a kind of succession where the gravitational pump come after very likely the mixed layer pump. From other modeling study, and here is comparison of 19 Earth model system model by the group of Stephanie Hanson. You have several emergence of the lack of our knowledge, if you want, in some way. Sorry. So here you have 19 models that are compared, and you can see that, for example, processes like fragmentation or zooplankton vertical migration are even not parameterized yet in these models. And you can see also that this means that we have potentially strong bias in the interpretation and the results of this model. And also, for example, the role of the phytoplankton size on thinking, also it's already beginning to be parameterized by some models. We are not, we do not know the directional change of future export due to this process. I mentioned these three because during the rest of my talk, I will make some emphasis on this a little bit. So, and also the interest in the Twilight Zone, it comes that we have a huge knowledge and observational gaps at the time where there is some, I would say, interest, economic interest in using this. And so this is not only for the pump sensitivity to climate change, where we are targeting our research, but also in some way, because there is the potential of fishing exploitation, potential perturbation by release from deep sea mining, not mentioning that was mentioned earlier, potential impact on the marine carbon dioxide removal and the fact that it could be affected by some of these too. So I will say that all this strategy and the way that our community is thinking now, we have to find ways to, in some way, circumvent our knowledge and observational gaps. And I will try to argue that we need to acquire comprehensive time series of export in key oceanic areas. And for this, I like the concept of phenology of export. This means that the succession and interplay of the various pumps together with their physical and biological drivers. And from this, the use of robots, and especially BGC Argo, could be of significant help and strong help, I hope, to evolve and to towards more comprehensive study of the biological carbon pump. So, for those who do not know, what is the typical 10-day cycle of an Argo profiling float? So, an Argo profiling float is a robot that is driven by change in buoyancy, and at the beginning of the 10-day cycle is descent to 1,000 meters, then drift for 9 days, and then back to 2,000 meters, and then take the measurements, temperature and salinity, and the variety of biogeochemical measurements during the ascent, where when you come back at the surface, it transmits the data to the satellite. And now we have two-way iridium transmission. That this means that we can make some kind of adaptive strategy. And at the same time, and I will put significant emphasis today on the fact that not only we measure vertical profile, but also we measure when we acquire data during the drift at 1,000 meters. That could be a nice way to better constrain, for example, the export production. So briefly about the biogeochemical Argo program, we set up the science and implementation plan in 2016, where we have several research topics identified, so including the biological carbon pump, the phytoplankton communities, the oxygen in zone and the nitrate cycling, the carbon uptake and the acidification. And at that time, we call this management topics, and the link with living marine resources and the carbon budget verification. So there are 6 core variables for BGC Argo program: chlorophyll A, suspended particle, downwelling irradiance, oxygen nitrate and pH. And the objective of a sustained array is 1,000 floats as soon as possible, I would say. So where are we? This is a map for last month. Here you have a representation of the deployment. When you have the blue circle here, this means that it's full 6 BGC variables that are implemented on the array. And otherwise, you can see that sometimes we have only 5, sometimes we have mostly oxygen. But for example, we can say that altogether, the community has achieved a third of the objective of 1,000 sustained floats. And here you can see the total profile acquired in 2023. And just to mention that for the chlorophyll A, we are, and backscattering, 2 optical proxy, I will make a lot of use here. We have already 120,000 profile acquired so far. So here it's an example of time series, one in the Southern Ocean and on the seasonalized zone. You can see the white bar, meaning that the float is acquiring data below the sea ice, and then after transmit all the data when the ice retreats. And you can see on this time series that if I take here the backscattering and the chlorophyll, you can see the seasonal cycle linked to the production of biomass at the surface. But these small dots represent spikes, and I will say proxies of large particle sinking in the water column and following the bloom. And here you have an example on the contrary, on the subtropical gyre, much less seasonality in some ways. You have a seasonality with temperature, but you can see a slight seasonality in the chlorophyll. In fact, the deep chlorophyll maximum is following the surface PAR and the penetration of PAR in the light. So this means that the seasonality of PAR sent the DCM closer to the network line, and sometimes, as a result, you have more production and possibly some particles identified by the backscattering coefficient that escape from the euphotic zone at specific period in the subtropical gyre. More detail on the spikes, and there is a specialist who is Nathan Briggs that during his PhD identify this as a very potential interesting proxy for particle flux. And here, to illustrate what does that mean, here you have, for example, a classical fluorescence profile, and you can see that we have biomass at the surface within the productive layer, but nothing at depth. This is the corresponding for the backscattering. And here we are in HNLC waters during a bloom period and on the western side of the Kerguelen Plateau. And you can see that we have some spikes, so the markers of large particles, only associated with the backscattering coefficient and not with the fluorescence. The reverse hold for the eastern side fertilized system. And so the interpretation, qualitative interpretation for the moment, is we have fecal pellets only here, and we could have fecal pellets and phytoplankton aggregate on the eastern side. Going a little bit, I would say, more in detail, Nathan used more than 30 bloom events in the North Atlantic and in the Southern Ocean, and where he tried to deconvolve the signal of the spikes between large particles and the remaining signal. And here you have a typical event when, as soon as you bin and aggregate more data, you can have a trace of the sinking particle, and the yellow line give in some way the sinking speed of this particle. But interestingly, you have, if I reproduce the line here, you can see that this sinking particle leave a trace of suspended particle within the water column, and this is interpreted as the scene of fragmentation of large particles into small ones. And the conclusion of this paper is that fragmentation could explain 50% of the flux of attenuation of large particles, and potentially, but we need more data to confirm this, fragmentation is higher in the Southern Ocean than in the North Atlantic. An illustration of, in fact, and I say anomalies, because you will see the spikes are in some way anomalies in the signal. And here is another type of anomaly in the signal. Here it's a profile that was done, I think, in the Labrador Sea. This is during night, and the day before at noon, you can see that you have some kind of signal here that you do not see here. And this anomaly in chlorophyll, in sedum, and in backscattering are the trace of vertical migration. I will not go in detail to how we resolve this, but you can see as a conclusion, as a utilization of this signal, Niels Enchen was able to, as a function of sun elevation and depth, to use all the data so far acquired by high float measuring particle with high resolution to showcase that we have a migration signal at large scale. And when we compare the Southern Ocean and the Atlantic Ocean, so the proportion of spike of signal of migration in the North Atlantic in red, the scale is 3.5, and it's 1 order of magnitude more in the Southern Ocean. Just an example of what we obtain with this. It's not quantitative, it's semi-quantitative and qualitative, but it allows to better constrain and to better have knowledge of what happens. So now I will try to illustrate how we can use the drift of the floats. I spoke only of the use of the vertical profile to better get a sense of the link between the surface, possibly, and the sinking flux here at 1,000 meters. So I start nevertheless. So this is a float deployed in Icelandic basin, and we had the 3 years of time series there. And here it's this time series. You can see in blue is the PIC derived from satellite, and in green is the chlorophyll concentration derived from satellite too. So upper panel is satellite. You can see here that we have a peak signal, so this means that very likely is coccolithophore blooms. We can see here the same panel, but that is the float measurement within the mixed layer. And you can see a good match between the satellite and what the float is seeing here. And you can see that we had a huge coccolithophore blooms for the year of 2016, I think. But, and now is the time series over the vertical of the float. Just to mention this here, it's the signature of the migration. But very interestingly, you can see the BVP signal, which marks the backscattering. So backscattering, because the coccolithophore at white place, and Grit will speak later on this, they have a strong backscattering signal result. And you can see this huge export of backscattering material for a long period that we do not see, for example, in the chlorophyll A response. And here comes the monitoring of the backscattered signal at 1,000 meters. And you can see that associated with this peak event that we had on the surface, it takes more or less 6 months for this additional carbonate calcium associated to the coccolithophore to reach the horizon of 1,000 meter depth. So first summary of what I have shown to you. So time series of vertical profile allow the quantification and characterization of various biologically or physically mediated pump. I didn't show a physically mediated pump. I removed my slide because I do not want to be too long. So Leo Lacour will speak of this later on during the meeting. NK process, for example, fragmentation. And there is an obvious link between 2 independent continuous records, so satellite 1, and including some information on community composition, and the signature of particle export at 1,000 meters. So now there are some area of improvement, and I will speak of more recent research that we have conducted on this. Sorry. So we have the characterization of phytoplankton community for floats. What can we do better? And explore the optical monitoring of carbon export in particular by targeting the 1,000-meter drift and the inclusion of new sensor. When I say new sensor, not core BGC Argo sensor. So I know that great Neckermans during our talk we speak of the paper of Louis Terrat that we were co-mentoring. So this paper was one of the first allowing to use the BGC Argo fleet and the signal in fact of the ratio backscattering over chlorophyll A together with some information of PIC from satellite to try to make a synthesis of what can be resolved by float. And you can see that in the North Atlantic, the Patagonial shelf, the Southern Ocean, and either Atlantic or Indian sector, we are able to resolve. And here we have, if you want, some kind of end member that say that outside this high latitude, we do not catch with floats some signature of coccolithophore. Another study that was more in detail, it was performed by Mathieu Ramboville as part of the cruise that we had in the Southern Ocean. And I introduced here a new sensor, the transmissiometer, that is here, the transmissiometer. And what we have conducted here, we measure the standard BGC Argo parameter, chlorophyll backscattering, but also the transmissiometry measurements that are on the float, and we put the same optical package on the rosette. And at the same time, we collect for phytoplankton identification, not only identification, but also sizing, microscopic sizing, plankton counting, and flow cytometry. And so we are able to make some reconstruction of the biovolume and the carbon associated to the phytoplankton groups through the optical measurements. We develop transfer function with these three measurements that we back apply to the time series of the float as soon as it is deployed. So here is the float, here is Kerguelen, you have Claustre here. So we catch here in this example, but in the paper there are numerous examples with respect to this. This is the proportion of diatoms and nanophytoplankton, and you can see that we have after the bloom of diatoms, we have a bloom or the augmentation of the biomass, relative augmentation of nanophytoplankton. And here I do not go into details, but this parameter is the size parameter. The average size of particle is another method that Nathan developed that use the information of the high frequency measurements at the upper surface of the ocean. And you can see, if you look at the blue line, you have a mirror of what independently another method is giving with respect to the community composition. So we are quite confident that these complementary methods allow us to better understand the composition of phytoplankton community or of the size of the particulate assemblage. So, however, for this, we need the transmissiometer, and you can see that is a database where you see that because BTP is a core BGC Argo sensor, we have mostly everywhere, and this card is in somehow all, but we have few data with transmissiometer here, definitely here, here, and here. So it's very few, and I will come back later on this. But for the moment, I would like also to mention that not only the transmissiometer allows us to get information, more detailed information on the phytoplankton community, but at the same time, and this is a method that was developed initially by Jim Bishop and later improved by Meg Estapa, so the so-called optical sediment trap method, where you can see here a record during the drift of the float. Here it's 48 hours. You can see this accumulation that you have on the facing up window of the transmissiometer. And the slope, we interpret this as a regular sinking material of, I would say, more marine snow material, where this is like jumps from this to this, is associated very likely to a large particle falling on the facing window of the instrument. So now, Louis Terratz this is a paper in press in GBC. He was using all the data that we get in the Southern Ocean, Indian sector of the Southern Ocean with the transmissiometer. And we try to specify and to categorize from the subtropic to the seasonal ice zone and on each side of the polar front, and using hydrological criteria to assign the various water masses. And here we select by hand the eastern Kerguelen plateau, which is in some ways some anomalies in this HNLC environment. And what we have done, so here the presentation is from the subtropic to the seasonal ice with iron fertilized area. And you can see the flux derives. So we had 2 or 3 years of time series, and we've been for each region as a single standard 1-year time series, all the measurements of flux. So here you have the flux for the subtropical gyre, and this converted, the accumulation of the attenuation is converting into a particulate flux of carbon, thanks to a new relationship that Meg Estapa has recently published, or at least the paper is submitted. And you can see here what we see from the subtropics to the south of polar front and either Kerguelen, we see an increase of this particular flux along this latitudinal gradient. And if we look the signal of the backscattering coefficient within the mixed layer, so this means at the surface, you do not see any variation. So this was quite intriguing. This means that we have a standing stock of particles that are more or less the same around this continuum, like, while we have a strong response in terms of community composition. And what we have done here now, we use the phytoplankton method that we had developed on the previous cruise. And again, you can see the balance between the microphytoplankton and the nanophytoplankton resolved by the optical measurements. And you can see that, as expected, the subtropical gyre is dominated by a small class of particles. And the iron fertilized plateau of Kerguelen, we had a huge diatom blooms. So in some way, we can explain that we have higher transfer efficiency 5 minutes. So I will have to go quicker. Yes, I can speak later. So transmission measurements are essential to make the link between surface phytoplankton community. Okay. Again, we had a new way also to say how we can go from the transmissiometer to use the backscattering as a way to measure the flux, but using the whole fleet of VGC Argo. So this is comparison of optical sediment trap technique and the new method that we have developed using the spike method of Nathan Briggs, but for the time series rather than the vertical profile. We end up with such kind of relationship where the large particle as a function of the flux, and for monthly flux for 4 regions, North Atlantic subtropical gyre, north of the polar front, south of the polar front, and east of Kerguelen. And then after, we apply this method to the whole data set of VGC Argo drift with the spikes, and we compare with the sediment trap data that we had at 1,000 meters. So you can see this is the subtropical gyre. You can see here the Northern Sea, and here you can see south of polar front. So there are some, I would say, agreements between the data collected by this indirect optical methods and the way to extrapolate to flux. So conclusion for this characterization of phytoplankton community, continuous monitoring of carbon export, and measuring increasing number of VGC variables simultaneous to allow better mechanistic understanding of the process. This is some highlight of the refined project, URC, just to mention that we develop a float that are additional refinement with respect to standard floats. So we have transmissiometer, we have measurement of hyperspectral radiometry, ED at LU, and we have the UVP on this. So 22 floats of this. So the UVP, I think this community is knowing the UVP. I will skip on this. And we have deployed so far mostly all these 22 floats. One will be deployed this week in Hawaii, and the 3 remaining are for your cruise, Stephanie, Patrick, next year in summer. So we begin to have time series. The longest is in the Labrador Sea. Just here, and we can have some kind of monitoring of the optical sediment trap flux, mostly in real time. So this is last week. So as soon as we have the drift, we try to convert this. And this in red is a time series of the UVP in terms of size class. You can see this is Kerguelen Plateau. This is west of Kerguelen. There is the Apero cruise, which is behind. And you can see that we can begin to, with the same method and some kind of interoperable data, we can cross-compare various systems. I skip on this one. Data UVP, we begin to have UVP data with, for example, time series for copepods. Sorry for the units, for the moment it's not clear, but at least in a relative trends is the case. You can see in Kerguelen Plateau that we have here some very strange and unique calanoid data over 1 month. You can see this kind of dynamics that we begin to have. For the optical oceanograph, we begin to acquire reflectance, remote reflectance at the ocean surface. And so I arrive to my conclusion. So final message, the technology seems to be ready for developing comprehensive time series of various pumps and process driving them. The next step, I think, is to implement, in complement to background BGC, which is low frequency, I will manage. Fixed variable, robotic process studies with enhanced BGC Argo payload. So I insist on this. We have interoperable data set for K location. The uncertainty still remains a big issue that we have to work on this. So we have to find appropriate location to maximize the return of such implementation. So we can use, I would say, the historic time series seat, because there is a science background for logistic constraints and for the calibration tools that offer. And also we have to work on the physical retention of the flow to minimize the replacement. And I didn't show here, but we begin to have, using machine learning method, strong link that we can develop between satellite and BGC Argo profile, especially for the optics, and integrated observation of ship, satellite, and robo. So I insist on BGC Argo here, but there is glider, there is time series by ocean time series station. So we try to, in some way, to summarize this view beyond BGC Argo as a community proposition for the community last year or 2 years ago, where it's described, I would say, in some way, the concept of future BGC Argo network more dedicated to JETZON, for example, targets. And thank you for your attention. Thank you.
Thank you, Hervé. That was brilliant. So, a few minutes for questions. Anyone has a question? Ah, you can't run away.
You could have taken more time.
Hi, I'm Karen Qualley from GNS Science in New Zealand, and I think that was a really interesting talk, a super exciting development. And I'm curious if there's capacity to look for microplastics with these transisometers.
For the plastic, I would say no. And I don't think the UVP, I look at Lionel, the response is no too.
Amazing talk, by the way. I was really interested in the possibility of using these data, specifically the time series data, for maybe forecasting, in the sense of, can we use that data to anticipate phytoplankton blooms or to predict how the carbon pump will be affected in climate change scenarios?
So the BGC Argo community is under pressure of the modeling people to deliver the data in near real time. So it's a big challenge because it is trade-off between assessing the quality of the data that the modelers assimilate in their models, together with the pressing need for having this. So definitely it's a tendency. It's more easy for the oxygen. So for example, at the European level, there is the Copernicus Marine Service that deliver weekly fields more or less in real time. And so I think the trend is to go for more real-time qualified data, but this is challenging in terms of human resource to manage it.
Very nice talk. I'm Peter Wiebe from Woods Hole Oceanographic Institution. I was in Europe over the weekend, and I saw an op-ed piece in the New York Times weekly edition, or the evening, the weekend edition, that proposed dumping iron particles to stimulate production over all of the ocean. And I wondered, based on your observations of iron introduction into the oceans off of Cape Wellen, whether you would anticipate that geothermal engineering in the future.
I'm not the best person here to speak of this, but for sure there are people that are thinking of this, and we have to be prepared in some way with such observational networks to be able to provide some constraints and help in the verification and the reporting part of this addition.
I was just wondering, you may have mentioned this and I missed it, but how are you getting your zooplankton IDs? Is it anonymously from the UVB data?
Yeah, it's embedded artificial intelligence. So, yeah.
Ken Bissler, Woods Hole. You mentioned this, but there are a lot of slides going by, and when you showed the POC trap slide, sometimes it seemed to agree with the optical flux, and sometimes there was a very big difference. So what do we learn when it's different? What are is it the amount of carbon per unit size that's changing, or is it a temporal thing where the flux is changing and the particle abundance? Is it what do you think causes that?
I think that the comparison, so we developed one standard year, so that can be interannual variability because we match the time series from trap to another year time series. So it's just, I would say, a comparison. This comparison has to be more seen as a first guess for a latitudinal gradient, I would say.
Yes. So would you recommend that we need more co-located, temporally at the same time, right?
Quite difficult.
Do this calibration.
When you have 1,000 meters, because yeah. So I think that the more data we will have, the more binning, and we will reduce the uncertainty. For the moment, the uncertainties are large.
Any more questions? Yeah, I should let them go to coffee. In which case, can I say a big thank you to our 4 speakers this morning for some brilliant talks.